Hello, dear friends, dear colleagues. I'm Ludmila Vesper, and I would like to present to you on Nash equilibrium in static games. The course introduces students to the tools of Nash equilibrium applying to economy and society conflict resolving. Students learn how to use some static game models for pricing, for collaboration in the market, and how cooperative games help us in business and social life. I will use some interactives and simulations to work out the ability to make decisions in the context of strategic interactions. Okay? As I know, you are already friendly with theory of game, and to be true, it consists of math a lot. In my lectures, I use a simple approach that can open your access to game theory in a very common way. But nevertheless, if somebody would like to deepen math with this topic, please don't hesitate to reach me in any appropriate way by email, by chatting, or via faculty blog. Okay? Okay. We agreed with the fact that people mostly don't like mathematics and like playing games. One more fact we need to accept: everything that is proven mathematically works in real life. We will call such cases model, and we will use model only for that proven by mathematics and experimentally, right? And now tell me, please, what kind of game would you prefer? Lottery, stock market, football, poker? Okay, maybe something else? Bitcoin market, cool. In the remaining games, we never know what our opponents will do. Those situations we consider as competitive or non cooperative games because as a result, we always have winners and losers. An important viewpoint in classifying games is this: if the sum of all payments received by all players at the end of the game is always zero. Is If it is zero, it means players pay only to each other. No production or destruction of goods is involved. All games which are actually played for fun are of this type, but not economically significant. They are the sum of all payments, the total social product will in general not be zero and not even constant. It will depend on the behavior of the players, the participants in the social economy. First kind of games we shall call zero-sum games, and those of another type non-zero-sum games, right? Okay. Do you know who is John Nash and what is his contribution to our everyday games? John Forbes Nash was an American mathematician who formalized some game situations by applying the Barnes formula in conflict resolution. I would like to give you all the necessary from the Nash equilibrium in much possible utility form. And of course, we will consider the application of the Nash equilibrium to the economy and social life. Okay? As we learn business, we will talk about business games. Let's work out some economy models. Case number one: the situation with only one player on the market. Such is called the Robinson Crusoe economy. Do you know who Robinson Crusoe is? Robinson Crusoe is assumed to be shipwrecked on a desert island. The basic assumptions are as follows: the island is cut off the rest of the world and hence cannot trade. There is only a single economic agent, Crusoe himself. All Crusoe's needs have to be produced or found from existing stocks. There is only one individual, Robinson Crusoe. He acts both as a producer to maximize his profit as well a consumer to maximize his utility. So, there we have a simple maximization principle. Robinson Crusoe model is an example of completely planned communistic economy. Okay? Case number 2. The two persons market, seller and buyer market. It is also equal to classical economy problem of bilateral monopoly. How do you think? What is the most important in this game between seller and buyer? Yes, right, price. In any case, in this economic model, the most important is price. And now please remind me what model means. Right. Yes, only that proven by math. Let's see pricing from a Nash equilibrium perspective. Now let's divide into groups of two. In each group, we have one producer and he is the seller at the same time and one buyer. For example, we have two players. You, Philippe, will act as a producer and you, Sophie, will act as buyer. Philip makes bread and Sophie needs bread every day. Both players are striving to get maximum. Seller most profit, buyer most utility. You, Philip, sell a bread and want to make the highest price of 4 euro. It's your strategy alpha, and you want Sophie to adapt strategy alpha. Philip has only one buyer. The buyer, who has only one seller, you, Philip, need bread every day. So today you, Sophie, buy the bread for 4 euro. Sophie adapts strategy alpha 2. But your income doesn't allow you to buy bread every day for those high price. For the next day, Philip would like to do the same, but Sophie doesn't come. So, you, Philip, lost your profit, and you, Sophie, lost your utility. The next day, seller decide to lower the price and propose the same bread for 3 euros. Adapts strategy beta. It's a more interesting price for the buyer and you, Sophie, stayed without bread yesterday. So, Sophie adapts strategy beta and buy bread for 3 euro today. Philippe inspires the possibility to get profit to the next day. But for the next day, Sophie doesn't come again. So, you two get together lost again. Look, Philippe, the cost price of your bread is 1 euro. The question is, what optimum price to sell bread every day? Who can say? Yes, surely, Philip, you're right. There is only one best price, 2 euros. So, you make the decision to sell bread for 2 euros. This is the price your buyer can pay every day for the bread she needs. And in the same time, it's a price of such called one solution. There is only one solution. From all dividing, each player receives the sum that not less of those he can provide himself. And they both get the maximum they could provide for themselves by the coalition. Okay? Okay. Case number 3, 3-person market. 1 seller and 2 buyers. We will consider this case after a little break. Thank you very much for being with me. See you later.